Okay, so this concept it's a little lab. So what you want to do is, for the piecewise function given above, find the area under the curve. Literally take time and find out the area. In case it's not super clear on the handout, it's 1, 2, 3, 4 over, and 1, 2, 3, 4, 5, 6. And then it's 2 more, and it's 2 more. And it's 4 more, then it's 2 more, and it's 2 more. So you end up over here at 5, 10, 15, 16, and 10 spaces high. So you want to find that area. Then we're going to find a C value somewhere on this interval where if I go boom like that, and then boom, boom, this filled in rectangle has the same area as that whole thing there. It does exist, it is here, and so I'm gonna let you do that. You should pause the video now, you should go do that. Whenever I watch videos and they say to do that, I never pause it. I'm not gonna do this for you. So you need to do it. Pause. Okay, so now that you did that, cool, you found out, oh, yep, this is, yep, there. So that's called the mean value theorem for integrals. It always happens. Assuming a function can have an integral taken of it, you will always be able to find a C value on that interval that has the exact same value as that integral. So, I don't remember what this says. Hey, all right, so it turns out that the integral is going to be equal to the y value at that C value multiplied by the length of your interval. That says b minus a. If you remember back to this right here, that height was just the y value of your function. And then the length here was b minus a. So that's kind of where that comes from. Not kind of, exactly where that comes from. And that's the mean value theorem of integrals, is that that will happen. Boom, that's where that is. So this, not super valuable, but it leads us into something different. It leads us into something very, very valuable, and that's called the average value. Oh yeah, I gotta do this problem. Okay, so remember that the mean value theorem for integrals just says that the integral is equal to f of c times the interval minus itself. So if I do this from 0 to 2, 4 minus x squared dx, that's supposed to be equal to f of c times 2 minus 0. I'm just plugging the pieces in. So if I take the antiderivative, I get 4x minus x cubed over 3, evaluated from 0 to 2. That has to be equal to f of c times 2.
First part of this interruption, just a reminder, high school students who are dismissed at 12:20 for last lunch will go to buses directly from the cafeteria at the end of lunch. All other students should remain in their current location, and that you will also be dismissed 2 buses by announcement from your current location. No one should transition from block 8 to block 9. Thank you.
That's why I'm filming this. All right. So f of c is equal, times 2 is equal to that. So divide this on both sides by 2. And so f of c is going to be equal to, 8 minus 8 thirds. That's 24, that's 16 thirds. Divided by 2. It's going to be 8. So 8 thirds is going to be what f of c is equal to. So now I've got to find out, okay, if that's f of c, what is c? And so that tells me that 8 thirds needs to be equal to f of x, needs to be equal to 4 minus x squared. So I'm going to subtract 4 from both sides. Yay, all these wonderful fractions. So I'm going to perform a little trick here. I'm going to multiply both sides by 3, and that's going to say 8 is equal to 12 minus 3x squared, just to help me think. So I get negative 4 is equal to negative 3x squared. It doesn't prevent me from getting fractions in the end. It just saves me a little bit of thinking so I can talk and think a little bit better. So I get x is equal to plus or minus the square root of 4 thirds, 2 over root 3. Okay, so which one of those is from 0 to 2? It's not going to be the negative one. So I can say that c is equal to positive 2 over root 3. Not the world's most interesting or useful theorem by itself, but with just a minor manipulation, we get the average value theorem. So average rate of change was something we could do, f of b minus f of a over b minus a. Now I can ask you, what is the average value of a function? And so this may look really messy, but it turns out that the average value is simply just do the derivative, then divide it by b minus a. That's what this formula is saying. It says 1 over b minus a times that. I may have said do the derivative a second ago. This is called an integral. You just do the integral, divide by b minus a. So this is really important because this, you can read it. So if we want to find the average value of this, I'm not going to do the work, I'm just going to do the setup. It's 1 over 4 minus 1. And you just do the integral. Very, very powerful tool to figure out the average. So, normal integral, all you have to do then is multiply by a third. That's it. So you're going to multiply your final end result by a third. So, that's the idea with these. Very worth your time to go through and do them. And so we should talk homework. Homework that you should do. Just fast forward until I come back. If you're watching this part, you should message me on Schoology and be like, Mr. Canfield, remember how you said that you get extra credit if you watch this part? Yeah, you could do that. Okay, so homework. So integral stuff that you should have already done. I mean, 4.1, 4.2, we should already have those done. We have not done 4.3, the method of substitution. Okay, so don't worry about that. That's actually coming next. 4.4, using geometry for definite integrals. That was something I wanted to go over today. So that's what we should have for today. Then 4.5, some Riemann sums. Should already done that. 4.6, the MVT and the FTC. That's what I want you to take a look at for next class. So certainly don't need to do all of them. But yeah, from 924 all the way to, you know, we've looked at 4.7 as well. So I'd say look at half the problems in 4.6, half of the problems in 4.6. So it's 924 to 953. And then please also for next time, check out 954 and 955. So two separate thoughts. And we'll talk about all this next class. I'll answer any questions you guys have. But like, I hope that this was helpful watching this. And hopefully YouTube lets me upload it. Go sledding.